Today we're going to be talking about why should your teacher or professor buy 3D printers for the classroom. When we're practicing engineers on the field, if we want to make a significant investment such as this, we have to make sure we have a very strong case as to why this is the correct investment over something else. So here we're going to make a really strong argument for why we would want to have 3D printers on site and accessible to all of the students. First, I'm going to talk about how students are going to benefit from having a 3D printer. And then I'm going to talk about how the teachers will benefit from having a 3D printer inside of the classroom. The examples of the benefits that I bring up, they kind of tie pretty directly to mechanical engineering. And when a lot of people think of 3D printing, they're like, all right, I know it's for the engineers, it's not within my realm, but this technology can help out so many disciplines in some very unique ways that I think are very cool. So I'm going to bring up some examples just to jog your brain a little bit and see if you can get some ideas flowing on how you can utilize this technology in a classroom. For the students, one of the more easy to understand reasons to have a 3D printer on site is that first-hand printer experience. So a lot more engineering firms and manufacturers are taking on 3D printing and additive manufacturing. And this is usually to supplement what they have. They combine it with their subtractive manufacturing. Maybe they are using it for their prototyping phase, but we're still kind of in the process of a lot of engineering firms converting. So this is a great time to kind of get ahead of that curve and understand this technology before you actually hit the job market. When you're 3D printing, there's kind of an art to getting your prints to come out correctly. There's just something about having your hands on your printer that can't be taught through video. And it's kind of an art to learning how to troubleshoot printers, learning how to toggle the settings to get the most optimal prints. That again only comes with experience, and that's really important. So now is a great time to learn this technology. When we think of 3D printing, especially if we're new to the 3D printing world, we might be thinking of that typical plastic filament extruder. The ABS PC, right? You might be thinking, okay, ABS plastic, polycarbonate, or maybe a blend of the two. But the palette of materials that have become available to 3D printers has expanded rapidly. So now you have all of these different material options available. Maybe you want to step up the ABS and have some carbon fiber in there. That is now an option for 3D printers. 3D printing is a huge doorway to CAD. So there are plenty of libraries, free or paid, where you can download files and you can print them out. But as you start to print out more, you might find that you have more and more specific proprietary needs to fit whatever project. It might be senior design or a graduate study. And when you get into that space, you need to be able to manipulate these 3D CAD files to fit your exact specifications. So SOLIDWORKS is a fantastic tool for this. This is a great doorway for students to say, you know what, I need to customize this file. I need to make a bracket. Let me go into SOLIDWORKS, learn how this tool works, and use this to create some 3D printable files. Lots of engineering firms have had CAD experience as a requirement. So this is a great way to kind of get into that realm by using 3D printing and needing custom designs that will be made in a CAD program. Prototyping is not a new idea to engineering firms. However, bringing in additive manufacturing is still relatively new. Depending on how many iterations you have, depending on what kind of manufacturing processes you have to go to make these prototypes, it could end up being very costly and very time consuming. They're beginning to bring 3D printing in, and it's making that prototyping process a lot faster because they have to produce less prototypes. And if they need a new one, it's just a matter of printing out a new one in a couple of hours and they have a new prototype to test. So because that is a workflow that is used every day in the engineering realm, this is something that students should be trying to parallel in class. So while they are prototyping these files to use for their projects, to use for senior design, they might think, you know what, I wish this bracket was a little bit thicker. I wish that this piece was a little bit longer. They'll be able to very quickly create that new prototype, which is going to parallel what they're doing out in the field. So those are the reasons that students will benefit from having 3D printers. Engineering is a very physical thing. Teachers can use 3D printing in a way that really portrays that information in a much more concise manner in a way that is much more clear to the students so they can actually witness the phenomena in their hands. It might just be an explanation as a 3D file, but having that will develop a further understanding in the material. This technology can help out so many other majors and disciplines in very interesting ways. So let's take a look at some of that. Now, in terms of biology, I actually see 3D printing really making a huge impact in two different ways. And one of those ways is replicating body parts to do problem solving without, killing the patient, which is usually preferable. So for example, we had this one case study where users wanted to 3D print a heart in their student lab so that they could do some problem solving to it. They wanted to be able to create some valves that will manipulate the blood pressure. So they were able to do that because they 3D printed something with like materials so that when they're problem solving, they have a pretty direct link between this practice and the actual, in the field surgery. So that is a very cool use. The second use I see 3D printing used in the biology realm is through biomedical and biomechanical applications. Now we have this one case study here where a student was missing an arm and he needed a prosthetics made. So they created one for him using 3D printing, and it was very accessible to him. It's very affordable because it was 3D printed. However, this team was very smart. What they did is they actually created the CAD files for his prosthetic to be expandable and to be able to grow as the user grew. So if one arm grows an inch, they'll be able to print out another arm at a very reasonable cost whenever they need to. Fine art and art history, we can just call this one art. And this is another one that I'm pretty excited about. So in conjunction with 3D scanning, what some users can do is scan a statue and 3D print it for display or for study. And the other thing that I think is really cool is custom material fabrication. So a couple of different ways people are doing this. One way is with prototyping. So if you're familiar with rendering or texturing softwares, you're familiar with things like texture mapping, bump maps. Those are things that can be used in a 3D print. The fashion industry is beginning to combine that with the textile manufacturing, and I think that is really cool. In this example that I have here, they actually 3D printed on top of fabric, and they were able to create this material that would have been, if not impossible, very difficult to make otherwise, and it's very intricately detailed, something very, very cool. So architecture, part of the curriculum is they want you to create these scale models out of little popsicle sticks and foam board to create these scale models, and rightfully so. These scale models have a huge place in architecture and civil engineering. You want to get a good visual physical representation of a scale of what this will look like so that you can make the best decisions before you start to commit. With 3D printing, not only are the prints going to come out looking pristine, but if they need to make a change once they printed it out, to manipulate that is going to be much more accessible through the CAD files and then 3D printing the new ones. So 3D printing is just going to make architecture, civil engineering a lot easier by making this information producible a lot quicker. These scale models are just going to be a lot more accessible. It won't be doing all this meticulous modeling to create these fine details. Even performing art majors can benefit from 3D printing. So when a theater needs, for example, a prop, this can get incredibly expensive. There are some details that they might want put into the prop, certain shapes, that can get pretty expensive, especially with sculpting. They don't have the tools in-house to create some of these props. Bring that in-house. Again, there are so many libraries online where you can find these files to just download and print out, but you can also make them yourself through a CAD software and print them out, slap on a fancy coat of paint on it. You got yourself a professional looking theater prop, and that is incredibly cool. People even in the hobbyist realm are doing something very similar. And even if you're not an engineer, there are plenty of ways that 3D printing can benefit you. And it's also a nice little way to kind of get your foot into the door if you are interested in the engineering realm. You want to get into design, you want to get into CAD software. 3D printing is a great way to get into those tools and those skill sets.